Hi, this video will showcase the intended workflow when making the initial setup of the vehicle using the custom vehicle controller package, as well as some tips and requirements. Drag and drop the vehicle model into the scene. The model should have the orientation according to Unity's standards. Forward is the Z-axis, up is the Y-axis, and right is the X-axis. All wheels should be separate models, with the center of geometry in the center of the wheel. Wheels should also have the correct orientation. Next, open the vehicle editor window. You can dock the window in the right part of the screen for your convenience. Make sure the root game object is selected. At the bottom of the editor window, you can lock the window. This will prevent the editor window from rebinding when you select another game object. In the Initialize Controller section, press the Add Component button. This will add all the necessary components to the game object. Next, drag and drop the wheels to their respective object fields in the editor. As of version 1.1.0, you can also optionally drag and drop the objects that represent the brakes. This will make sure the brakes will copy the wheel's transform properties, but ignore the rotation along the x-axis. Also, you can optionally drag and drop the vehicle body. This will place the center of mass in the middle of the car's body. Click the Initialize Controller button. If the game object is a prefab, you can unpack it from this very same window. As you can see, the hierarchy of the game objects changed, and the main scripts received the references to the newly added components. When initializing the controller, the wheel controller components were added. If the wheel game objects that you assigned had the mesh renderer component, then the radius will be calculated automatically. Otherwise, go into the isometric mode, enable the gizmos, and change the wheel radius properties value to match the wheel's size. You might have also noticed the rectangle being drawn. This is the suspension. One of the properties of the Car Visuals Essentials component restrains the wheel from going beyond this position so that the wheel model doesn't glitch through the car body. Lift the game object with the suspension controller script as high as possible, to the point where the suspension should start from. The next important thing is the center of mass. In the real world, it is not in the center of the vehicle, but closer to the engine. In the isometric mode, adjust its position accordingly. I recommend not moving it to the rear, even for the rear-engined cars, as the stability would leave a lot to be desired. The next thing requires attention if you have complex colliders on the vehicle. If you use multiple primitive colliders or a mesh collider for the vehicle body, then set the game object with colliders to a separate layer. Let's create a new layer called Vehicle and assign it to the game object. Next, set the Ignore Layers property in the Vehicle Controller component to the recently assigned layer. While we're at it, let's review some other properties of the controller. The Suspension Simulation Precision defines the number of raycasts along the wheel. You are recommended to keep it at least at 3 to give the wheel more chances to connect with the ground. The Forward Slipping Threshold defines how much wheel spin is allowed until the car will be considered wheel spinning. The wheel spin occurs when the acceleration force is greater than the wheel load multiplied by the tire grip. It is used to display visual effects. The sideways slipping threshold defines how much the car is allowed to slide before it will be considered slipping. The amount of slip is calculated as the dot product between the vehicle's right axis and the vehicle's velocity. It is used to display visual effects and decide whether the car is drifting. The drivetrain type defines what wheels cause the vehicle to move, and the transmission type defines whether the gears will be changed automatically or from the user's input. The engine parts customization came in update 1.1.0, which we'll talk about in more detail in another video. The last thing on the controller is a container for the vehicle parts. You have two options. You can individually assign parts one by one or use the preset of parts. You would want to use the first method if you intend to change the parts on the vehicle, for example for performance customization, and you would use the second method if you know you won't change the parts on this car ever, for example for the pre-made AI cars. Let's not forget that assigning the same instance of a scriptable object would make the changes to this scriptable object affect all the users, so it's not suitable for performance modifications unless such a behavior is intended. Changes to all these fields can be made from the code. Refer to the official documentation to learn more. The link will be in the description. So, let's assign a preset and test out the car. It should be perfectly drivable. I will also use a camera that I made using the Cinemachine package. Don't forget to add the input provider script. If you have the input system package installed, you are recommended to use the Vehicle Input Provider Demo component. Otherwise, it will not be available. You can also create your own scripts that provide input. Refer to the documentation for more information and examples. Also, if your game will involve uneven surfaces, ramps, and whatnot, which will make the car collide with the ground, consider assigning a frictionless physics material to the ground, like the one that comes with this package. This will make the car not lose any momentum after landing. As a bonus, Custom Vehicle Controller also comes with scripts and visual and audio assets for handling different effects, such as tire smoke, turbo sound, anti-lag, engine sound, etc. So let's spice things up. Add the Car Visuals Extra component. Drag and drop the game object with the Car Visuals Essentials component and click the Copy Values button. Click on the toggles of the visual effects you would like to use. For most visual effects, you have a choice of whether to use the particle system or the visual effect asset. The particle system assets are located in the Custom Vehicle Controller Demo VFX Particle Systems folder. For the brake lights, drag and drop the mesh renderer for the brakes game object. Select the HDR color and set at what indexes to change the material's color. For the anti-lag and nitro effect, we need to have the positions where to emit the effects from, so let's create some game objects. For the wing arrow effect, add the trail renderer prefab, position it correctly, and assign the references. Okay, let's check out the results. This surely looks much more interesting. We can also change the properties of some effects. Let's change the color of the nitro. Now let's add some sound. The package comes with some audio assets, but you can also use your own, of course. Refer to the documentation to find out how to make scriptable objects for the audio effects. Let's add the components for handling audio. Add the Engine Sound Manager script and populate the fields with the appropriate references. Do the same thing with the Vehicle Extra Sound Manager. Also, add a reverb zone. This will use the selected reverb preset when using Nitro. This concludes everything you need to know concerning the vehicle setup. In the next video, you'll learn how to create different vehicle parts and what their fields do. See ya.